All right, we're ready. Do you want me to start?
Sure.
Do we need to read the paragraph, or do you want me to just go? I can read the paragraph for posterity, I guess. Recorded posterity. A Nova, according to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poet dies young, for she is restless and will not let them remain long on earth. One study designed to investigate the issue examined of the age of death of writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and nonfiction writers. The ages at the death for female writers is in these categories for North America are given in the Woman Poet Excel. You would like to determine if the mean age of death is different from any of the categories of writers. Use alpha 0.05 as a level of significance. Design the study. What is the research question? Is the mean age at death different from any of these categories?
Which is the answer to A.
Yeah.
Mm-hmm.
I mean, that is the answer to A. What is the mean? Yeah, okay.
Right.
Then, do you want me to do B too? State the null and alternative hypothesis?
Sure.
The null hypothesis equals all means are equal, and the alternative hypothesis is one of the categories differs from the other.
And that's stated. That looks like Q1 is equal to Q2, right? Is that how they write that in an equation?
No, it's this. They actually have it written out.
Yeah,
Oh.
H little 0 equals all means are equal.
Mm-hmm. Yeah, it's not mathematical symbols. It's English.
It's actually written out.
Yeah.
Alrighty. So 2, it says collect the data. Describe the data collection procedures. I put that it was a stratified simple random sampling, but I'm not sure if that's what they were looking for. It says the rule, because the answer sheet says the rule is if the largest variance is... Oh, wait.
I mean, it doesn't really specify like if they took like a random sampling or how the sampling was done.
Right, yeah, it just says that they
don't know exactly how the data was collected. We only know that they looked at the ages of death for female writers in North America. That's what the answer is on the answer sheet. I thought that was kind of a weird question.
Yeah.
Mm-hmm. But basically it is right, because based on the scenario, that's all that we're given.
Yeah. Other than the actual data.
Uh-huh.
But I think that's what they would have used, Wes, to answer on your topic. I think that's what they would have used, because they have...
Yeah, they have data classified into 3 different groups.
And they used all of all of the random samples from each group.
Mm-hmm.
Where if they would have, well, they couldn't have done it the other way, because that would have taken out one of the groups. But yeah. And I think this is the next question is kind of weird too. In a short paragraph, summarize the statistics. I mean,
yeah. Use the summary of statistics to describe the data, and it's
this is similar to the one that we did last week, whereby we gave the mean, and the standard deviation for each category.
Yeah.
Right. Yeah. And that's all they have on the answer sheet, except for the box plots. Now, can anybody tell me how to do a box plot? I mean, I try to Google like how do you make one.
Oh.
I know that like SPSS like does it for you when you put it in there, but
isn't there a way to do it in Excel?
Yeah, it prompted me, but I couldn't get it to work. But there is when I clicked on right-clicked on the data, it gave me a prompt to do other charts or graphs. And so I went through there, and there's a way to do box plots in there, but
Yeah, I think it's under insert. I'm using Excel. I think it's under insert charts. More.
Oh, I see.
And then box and whisker.
yeah.
Yep, that's it. Let's see if it works. It looks like it works. Let's see. Does it let you, that's style. I don't know if it'll let me.
Did you have to go into templates? Like, where did you get box and whisker on that?
Oh, so I selected the data.
Right.
And then I went to insert.
Right.
The insert tab on the ribbon. And then there's a section for charts.
Uh-huh.
And then there's one that looks like a scatter plot with a down arrow. And I clicked on that. And then there's the last option says more scatter charts.
Uh-huh.
And then it brings you up more scatter charts, but it also brings up, I think if you clicked on recommended charts, you could also get to here. And then box and whisker is one of the options on the left.
But I think
I
you
don't have that.
do
Yeah,
for
recommended charts and then all charts. Are you using which Excel are you using?
I think I'm using 13, to be honest, but
Oh, it's probably different then.
which one are you using?
I'm pretty sure this is 16, I think.
It's the one I downloaded from BYUI. Let me see what this is.
I think though that you have to do each set of data separately, and then copy and paste it on a blank sheet.
Oh, I see what you're saying. Yeah, but
You can't do each one together, or all of them together.
all three of them.
Yeah.
I want to tell me.
Yeah, I think I don't even know what it would, like how to look that up. Account maybe? Microsoft Office 365, I think.
What are you trying to look up?
Yeah.
What version of Excel he's in?
Oh,
I'm at. Yeah. Let me see.
About Excel. Yeah, I'm in 2016. So if you go to File,
Uh-huh.
and then Account, and then there's an About Excel section. If you click on the button,
Yep.
it'll tell you in green, or at least mine's green.
2016.
Yeah, so
oh yeah, 2016.
I'm not sure why it's, yeah.
That's weird. Okay.
I'll share my screen. I should have done that. I should have done that. Let's see.
Yeah, it's always easier to do it after the fact.
So I select my data, or right here, and then I go to Insert up top here.
Uh-huh.
Oh, hit it. There you go. Insert, and then this one right here. Or you could even do recommended charts, and then click all charts, and then box and whisker.
Yeah.
Yeah. That's okay. I mean, I'm doing the same thing, but I don't have that option. That's kind of weird.
Huh.
I wonder if I need to select. Hold on. Let me select a different set of data and see if I can do it.
I was gonna select.
All charts. Oh, so I wonder if it was because it was I had it on a different set of data that wouldn't have worked with a box and whisker.
Possibly.
Interesting.
Yeah, because if you select the whole, yeah, there you go, the whole thing, it
Yeah.
all of them.
It does do it for all of them?
You have.
Yeah.
I had to select all of them, all the data.
Well, that will make it easier if it actually does it.
So you select all three?
Yeah. So I
Okay.
just selected from there down to. So I started at that box, selected up to there, insert, recommended charts, all charts,
Box and whisker.
box and whisker. Okay. And then the result.
Well, that's good to know. I don't know if we'll ever have to need that, but I mean,
Now you know how.
now we know how. Yeah, because I was like trying to figure that out because, I mean, this box plot looks like the one off the SPSS when he does that.
Yeah, theirs is oriented the other. It's
The other
like,
way. Yeah.
yeah.
Cool.
I don't
Man.
know if you can. Whatever. But
So, did everybody get the same? I don't even have.
what?
I was working through the
What were we on?
yeah the describe the data.
Oh,
So the novelist, the sample mean was 71.448.
I
The
wonder this.
sample deviation was 13.052.
Yep.
Oh, yeah, that data I'm pretty sure is this. Let's see. So, yeah, the means I got were 71.448, or I guess no, you're only looking at the ANOVA test section, right? Or is it the descriptive statistics?
The ANOVA.
ANOVA, yeah. So the difference between groups, within groups, and then you're looking at the.
Let me get caught up here. I was doing the exam, the review, so I've got different
Oh.
data files up here. Let me get this. And then who's having a party? I can hear a party going on in the background.
One of the girls who live in one of the complexes nearby. Yes, UI. So so everybody's in our living room. So that's why.
And you're in here doing homework.
Yep, I'm in here doing homework.
I do. All right, you guys can keep going. I'll catch up.
Okay.
Right. So, 7A, what type of hypothesis test is appropriate? And that's ANOVA.
Yep.
If that's pronounced right.
That's what? Sorry.
ANOVA.
Yeah, ANOVA
test.
No,
Oh, ANOVA. Okay, yeah.
Yeah. And then what are the requirements for this test? Is what is it? The variance needs to be the same, right? They need to be
equal.
And then the data needs to be normally distributed.
Correct.
Or yeah, it's just the means of the data, right?
No, it's the data itself.
Yeah, the data needs to be distributed normally.
So what was the because it talked about right skew something, it was right skewed somehow.
The F.
The F test.
Yeah.
The F statistic. So did anybody find where you could like do that test, or was it just given to us?
Just given to us.
Yeah.
I read it in the reading, it says it should take you like hours to compute by hand.
Right.
Yeah.
But well, the thing I couldn't figure out was like, okay, so we have the applet and we have the T-stat applet. Like, where's the F-stat applet?
Yeah.
I couldn't find it anywhere. Okay.
Yeah, but I don't think, because that value, like it said, was it's just computed by throwing in the data, I think. I don't know if you're going to try and compute that with using like the standard deviation and F score. I mean, you know what I mean?
Okay.
Because before you were trying to find P using the F score or the T score and a Z value, or no, whatever. You're using the Z and the T score to find the P value using the applet. But this one, it's more like, it's more like the result of data instead of like something you would compute by hand.
Yeah.
At least that's what I got from the reading.
Okay.
So C?
So C, yeah. Are the requirements met for this test? So I've got the QQ plots show normal distribution on the 3 groups, roughly.
Yeah.
And the large variance 299.190 is not 4 times larger than the small variance of 170. So that would mean that the variance is equal.
Yeah.
I wonder how they came up with 4 times.
Yeah, I don't know.
It's kind of like the end 30 makes it normalized, or is big enough for it to be normal.
I wonder if you can, depending on the size or the test that you're doing, you can adjust that. Just like with the size bigger than 30 is considered a large group.
Mm-hmm.
Yeah.
Who knows? I'll take it though. It's one less thing I gotta have a test on.
Right.
Right. So moving on to the next question, it's compute the test statistics. It's 6.563.
Which is the F value.
The F value.
Right?
Yes.
And then the degrees of freedom are 2 and 120.
Yep.
2 between groups and 120 within groups.
And 120 within groups counts each piece of data within all groups, correct?
But then
so there's 122?
Yeah, if you look at the answer key, they use the total, the 122.
Interesting. So is it n minus 2 then in this?
No, it seems like they just took like the between groups and the within groups and they added them together to get the 122.
Yeah, but what I was reading is that you always just keep them separate. You just put both values down when they
which is similar to the n minus 1. Is that correct?
Right. No, that's what I'm saying. If it was n minus 1, let's see, there's 6 to...
Would have got the same value.
Wouldn't it have been... Hold on. Because I think 72 minus 6 is 66... 57, no, 37 minus 6 is 31, and 29 minus 6 is 23. Yeah, so 120 is n.
122?
You got 120?
No. 123 is n, minus 1, that's 122.
I must have done my math wrong.
Because 67 plus 32.
Were you adding up 24. All the different sets of data?
Yeah, that's what I was trying to do. But I think here in the data. So there's 123. Yeah, you're right. Yeah, there's 123. Interesting. So where do they get the 120 from?
The 122 is within groups. Yeah, so the 122 is for The 122. In fact, if you look at the 122, the formula for the 122 answer, it shows that they took the total n and subtracted 1.
Oh yeah, and the other one is just J17 minus J15. J17.
Yeah, it's the 122 minus the 2, like the total minus the between groups 1.
Where are you guys at? I'm getting lost.
Oh, we're checking the DF on the ANOVA test.
Are you in the chapter 14?
Yeah, on the Excel file, on the homework.
Yeah,
Okay.
we're on the Excel file. We were looking at the formulas for within groups of, what is it, the degrees of freedom.
Right.
So within groups in total, so the total number of data, if you add up each data set, the n value of each data set, you're going to get 123. And so the total degrees of freedom is n23 minus 1, or n minus 1, which is 122. And then you get within groups value is the 122 value minus the between groups.
So the between groups, is that saying like in between variable 1 and variable 2 is one in between, and then variable 2, variable 3 is another in between?
Right, yeah.
So if we had another variable, we would have actually 3.
Right, yeah.
And then the other one would be 119. No? Or would that be different?
It depends on the value of how many were in the
fourth
variable. Gotcha. But yeah, the idea of that is correct, yes.
Okay, gotcha. I see what you're saying.
Yeah, because if I just put one more data in 1, it didn't, because total went up.
When you put in 1?
Yeah, total. Well, no, it's still correct. It's still correct because you put in 1 and it's still 120. Because, yeah.
Well, I just added another piece of data onto variable 1, and it gave me a total of 123. Oh yeah. And then 121 instead of 120, and then 2 in between.
Right. I put a piece of data in variable 4, and it never mind. Yeah, we understand it.
Yeah, no, okay, I just did the same thing. Okay, I got you.
So there's that. That's the degrees of freedom.
Another tangent. What else can we go off on?
Well, the p-values next. So
Yeah.
Sweet.
Okay, compute the p-value and compare it to the alpha of 8. No, I mean compare it to the alpha level.
okay, and the alpha level for this was the 0.05, right?
I
believe so, yeah.
And the p-value is 0.002.
So we reject.
Yes.
Because it's less.
Right. So that's G, make the decision. So we reject it, and it says you'd say that we reject the null hypothesis because there is sufficient evidence to suggest that the
at least one of the means of the
Is different.
deaths is different from the rest. Yes.
Yeah.
Okay.
I hope we don't get tested on trying to write out one of these things, because there's no way I'll get it right.
Yeah.
It'd just be multiple choice, and it'll have.
That's fine. I can do that. But if they have a blank space and they're like, write it out, I'll be like, oh boy, I'm done.
Yeah.
Sorry, I didn't get this one right.
Yeah.
Type that in there.
Oh man.
Okay. And then 5th is take action. So.
With further study, we find the poets die earlier than the novelist and nonfiction writers. What significance can you conclude from this?
Don't write poetry. It's bad for your health.
Yeah.
I thought. Yeah.
Poets are always drunk anyway, right? Isn't that what the deal is?
Oh, so there's contributing factors.
Yeah, that's what it
It's
is.
not that writing poetry gives
It's
you.
not that they're writing bad poetry; it's that their lifestyle.
The poet's life.
Yeah.
Oh boy!
We don't have enough evidence to make that.
Right.
Okay. Well, move on to the test then.
Let's do it. Reading, community quiz, collaboration.
Everyone there?
Yep.
How many files are we going to have to open up?
Looks like two.
Okay, so we'll begin with question 3. You all ready?
Uh-huh.
So in an ANOVA hypothesis test, we reject the
Null hypothesis.
the null hypothesis when there's sufficient evidence to indicate that at least one mean is different from the others. That is true.
Yep. And then question 4, what requirements need to be checked when performing an ANOVA hypothesis test? It says data groups are normally distributed and variances are equal in each group.
Correct. Oh, to check, number 5, to check if each group is normally distributed, do the following. Construct a QQ plot for each group.
Yep. 6, we assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance, B.
Yeah.
Yep.
7, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 1, 2. How many pairs are there in 4 samples?
This is what is that? Is it an exponent? What it's because you're gonna have 1. You're gonna have 1, 2, 1, 3, 1, 4, 2, 3, 2, 2, 1, 2, 3, 2, 4, 3.
Okay.
1.
So 1, 2, 1, 3, 1, 4, 2,
Oh,
1.
wait, no. Yeah, it's just it's like
I got
comparing.
6.
Isn't there's an equation for finding this?
Is there?
Yeah, somewhere.
There is. I don't know what it is though.
I mean, was it in the reading?
No,
Oh.
I don't think so. Not that I saw.
Oh, you mean there's just to figure out how many different variations of something?
Yeah, I think it was in the fundamentals of math. I think it was in math.
But somewhere though, in the reading, it said that if you had 6 samples, you'd have to do 15 different tests to.
Yeah, I remember reading that.
Yeah, so it becomes exponentially greater, but
Yeah. So they all have to be compared to each other, right? At least once.
Yeah.
No, only once.
Only once.
Yeah. So 1.
Okay, so we 1, 2, 1, 3, 1, 4, and then we've got 2, 3,
2, 4.
2, 4,
and
2,
3,
1.
4.
and what?
Oh,
And
yeah.
3, 4.
And 3, 4.
Yeah.
So we're going with 6.
Okay. So it should look like a pyramid, or a reversed 1/2 pyramid.
Yes.
A triangle, rather. Oh dear. I have horrible ways of explaining this. It makes sense in my head. Let's see.
We're doing fine. We're doing all right.
Download the soccer.
Okay. Which one is soccer?
I was reading. I should have saved it.
Oh, the soccer one. Is this the soccer shoes?
Yeah.
I think that, is this the same?
Yeah.
Oh. It says the data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, and E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. And then question 8 is, what is the minimum or smallest variance for the 6 groups? So I need to...
So we need to enter all these.
Yeah.
Mhm.
All right.
A, B, oops. Copy, paste. And then just socks. Oops. Paste special. So the smallest variant is 27.208.
And I'm not that fast at putting this stuff in.
Yeah.
Did you put the socks one as well?
Yes.
Okay.
Excuse me.
Okay.
I got variable 3 as the smallest.
You mean the C?
Is this what's that? What's the question?
Yeah. See,
What is the
so
minimum variance for each group?
for the 6 groups.
Oh, I see what you're saying. Yeah, 27.208.
Yeah.
27 point. Oh yeah, 27.28. Yeah.
Yeah, so it'd be the C group.
Mhm.
Number 9. What is the maximum variance for the 6 groups?
Third?
Oh,
That's 53, 158.
Thane, we're looking at the descriptive statistics in
Yeah.
the quantitative inference procedures.
But the smallest I got was 52. Is that right?
Mm,
No.
52. That
smallest?
is,
Yeah.
That's close to the biggest.
All right. So what data is it's thrown in there?
Did you get rid of the old data that was in there?
Yeah.
maybe could you share your screen so we can see?
No, it's on another computer. So
Oh,
let me.
Here, I can show you mine and then see how yours compares to that. So here's all the variables here, and then here's the smallest, which is 27.208. Sorry.
Okay. To 7.2. So largest then?
53.158.
53.158 is what I got. 158. And then 10 was test for equal variances as satisfied for these. Does that make sense?
The
Yes.
test for
the
equal
test
variances is satisfied for these
Okay.
data.
Sorry.
So that means that the smallest times 4 is less than the biggest. Does that?
Yeah.
Did I say that right? That didn't make sense.
Yes. Or the biggest divided by the smallest is less than 4.
Yeah. Yeah.
Which
So
I believe it is.
10 is true, right?
I didn't calculate it, but
Yeah. Well, 27 times 2 is going to be over. Well,
Yeah,
it's going to be right at 53. So.
but at least that's 2. Needs to be
Yeah.
twice that amount.
Wait, how did you guys do it? I'm confused.
So the largest variance is 53.
Uh-huh.
And in order for it not to be equal, that the largest variance has to be 4 times bigger than the smallest variance.
Oh.
So for it to be not equal, the smallest variance would have to be 13, less than 13.25, in order for it not to be equal. So if it's, and obviously we're way above that. So does that make sense, George?
Yeah, I'm just getting a pen so I can write it down in my notes so I don't forget.
Yeah, that's one of those numbers you need to write down.
Yeah.
And then it says to create a QQ plot for the 6 samples.
So in our case of this one, it's false, right?
No,
it's true.
True. Yeah. So they are equal.
Yeah.
If the smallest times 4 was greater than the greatest amount or the greatest variance, then it would be false.
Yeah, because it would be unequal variances at that point.
Okay, so basically what you're saying is that in order for it to not be equal, the smallest times 4 must not be equal to the highest, right?
Must be greater than.
Must be greater than, okay.
Yeah, if it's great, if
it must be less than the biggest.
To be equal.
Yeah, to be unequal. Isn't that what he said?
No, yeah, to be unequal, the smallest must be 4 times what?
So to be unequal variances, the smallest has to be smaller. Well, the smallest times 4 has to be smaller than the biggest.
Okay.
Am I saying that? That doesn't.
Yeah, that's right.
Yeah, it just doesn't make sense. But yeah, I mean, it does. But I'm probably ending that.
I don't know. I was trying to find in the book where it said it, but.
Well, it's right here. I got it.
Oh, if the largest variance is less than or equal to 4 times the smallest variance, then you conclude that the variances are equal.
I'll be right back.
Yep. Okay, so oh man, so they're really going to make us do this.
Yeah.
All right, I'll zap them out real quick and see if we can.
Well, I'll start on socks and go backwards.
Okay.
So.
Okay, is anybody doing the Q?
Yeah, that's what we're doing right now.
Okay. I just want to make sure I'm not doing it by myself. Okay.
So the first 1, 2, and 3 seem to be more than what our example, and they said that was close enough. So
Yeah.
I'm not finding anything that's very S-shaped.
Yeah.
At all. So
The,
I mean, we got a 50-50 shot, right?
The socks were probably the most skewed, but they were still pretty normal.
Yeah.
So
I mean, we got a 50-50 shot on this, right? I'm going to go with the true that they are normal based.
yeah.
Mm-hmm.
So
based on what I see, they look approximately normal. I don't see
Yeah.
any weirdly shaped one.
yeah. Wait, where you at?
So I hope they don't expect us to have SPSS because I don't have that system.
Yeah, well, they did
Yeah.
it. They told us to get Excel. So
Yeah.
Yeah, I don't have SPSS either.
Okay, so let's just try it with. So what do we have for our p-value right now? We have 0.0809, which is 0.81.
Mm-hmm.
So we still have that p-value. So let me just.
You mean 0.081?
Yes.
Yeah, okay.
Let me just remove contents for socks, and then my p-value goes to 0.309.
Which is greater than the one that we have with the socks. 0.309, what is that? What is
Yeah.
that?
0.3, well, what are we rounding to? 3 decimal places?
yeah.
Uh-huh.
So I've got 3092, so 309.
Okay.
0.309.
309.
The test statistic for the ANOVA hypothesis is an F statistic. Is the p-value the area to the right or the left of the F statistic? It's always the right.
Yeah, it's always in the tail.
Yep.
So
You with us, George, on that one?
Yep. Which one? We're
Question
doing 12, right?
Oh, 12 is 0.309.
0.309. Uh-huh.
And then 13 is right.
The pivot area is to the right. Why is it to the right? I don't get.
So in the reading, the F test,
Uh-huh.
it says the F test is always right skewed,
Okay.
and the it's always to the right of the F value.
Okay. F test is always right skewed.
Yeah, where's the F test? There it is. So the F distribution, we use a brief summary of the F distribution. It is right skewed. The value of F are never negative, and the p-value for the ANOVA test is the area in the right tail. We never divide the area in the tail. So
Okay. Value of F are never negative, and the value is always in the right tail.
yeah.
Okay. Thanks. Okay, so moving on to 14. That's when we do the other one. We download the hot dogs nutrition.
we do. So we doing the calories? Is that what we're getting, or the sodium? The calories and the sodium.
I'll bet we do a little bit of both, huh?
Analytics.
Because of hot dogs for each of the food they cook.
Calories.
No, but then it says let's examine the calories first. So we begin with calories.
Yeah.
Construct QQ plots for the calories of each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. And boy.
I'm still copying data.
Okay.
I didn't plug in my mouse today, so I'm a bit slow.
And for beef looks pretty normal. There's a few points off, but pretty normal. But it's crazy that there's beef, meat, and poultry.
Yeah.
What's the meat? Is it mystery meat?
Well, didn't it says in here, didn't it? 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 50% poultry meat. So it's beef, chicken, or well, poultry. I guess they would consider what? Turkey and chicken. And then the meat is a mix of all 3.
Yeah.
Leftovers. Lips and butts.
Boy.
Okay, let me.
What are we doing there? Okay. Yep.
Okay, you guys have your Q plots?
Just about. I'm getting there.
Okay.
Oh, man. I'm not copying and pasting very well tonight.
Yeah. Thing is mine doesn't get rid of all the old data, which is annoying.
In the QQ plot?
And the other pages as well.
Oh, so what I've been doing is I highlight the data, and if you right click, there's something it says clear contents.
Yeah.
If you want me to, I can share my screen and show you if you'd like me to.
No,
Okay, got it.
Yeah.
That's what I've been doing because I've had the same problem where I keep on coming up with the wrong stuff, and then just because I don't clear everything else out.
Yeah. So the meat one is the one that has the furthest, or the more points that are scattered, but they're all fairly normal.
Man, yeah, I see your point.
Yeah, because I mean the first 2 look like normal to me. Like the Q plots. And then yeah, third one is the one that looks like somewhat different.
Yeah.
Because I don't know how you guys just like once like look, but then hang on, let me share my screen then. Screen share. Because this basically kind of like the ones that I got, this 3 here. Like this first 2, like they look pretty much like more similar, like more normal.
Well, those are plots.
Yeah.
Those are QQ plots.
Wait, are we doing something different?
Yeah, we're doing QQ plots.
Oh, QQ plots. Okay. Hang on.
You have to use that other Excel spreadsheet. Remember the first one we used at the beginning of class?
The one with the quantitative?
Yeah.
Okay, and then just copy all the values in there.
Yep, and then you got to go to your QQ plot. No, you got to go to your QQ plot sheet.
Okay, hang on. Okay, okay, so now I'm gonna paste the values in here.
Not on that sheet. You got to go to your next sheet, where it says
QQ plots.
Yeah, QQ plots.
Oh, gotcha. Oh, wow.
And then you have to sort smallest to largest.
Smallest to largest.
No. What you doing? Undo.
George, are you still sharing your screen?
No, it stopped.
Oh, okay. Did it line up better when you did the sort?
No. Oh, you mean in descending order? Is that what you mean?
Yeah.
Yeah.
Wait. Okay. Let me share my screen just to make sure I'm doing the right thing. Okay. Sort and filter.
Yeah. Short.
From small to largest.
Yes.
Yes.
Okay. All right. There it is.
Well, do you have all of them?
Yes, I believe so.
Yeah. So you need to do what you're supposed to do according to the reading is you have to do a QQ plot for each group separately.
Yeah.
Oh, for each group separately.
Yeah.
Okay. Okay.
But
Gotcha.
that looks a whole lot more normal than the ones I had. But
Yeah, maybe it's because that one is just like all of them.
yeah.
Gotcha.
I don't know, Thane. Do you feel like the QQ plots of?
I think they're about as normal as one example was.
Yeah, I mean that's true.
That one example in the reading was pretty
S-shaped.
Yeah.
And they said, "Oh yeah, that's close enough." I'm like, "Wait a minute, that's not what we had in the other ones."
Yeah.
So
I think we're safe there.
Have been met. It's safe to assume that each group comes from a normally distributed population. From the QQ plots, we can also assume that the variances are equal. Oh, that we can't do yet.
Yeah.
Do we need to check the variances?
I'm putting it in the other table now.
Oh, here, let me catch up here.
Wonder where Wesley got off to.
I don't know. Was he the one coughing?
Yeah.
Okay, he might be.
Let's
see what we got here.
They're within range.
So, Control-C.
But just from the looks like the meat is gonna throw a wrench in the final test.
Is it?
Yeah. Because the beef is 158 and the poultry is 156, and then the meat is 118. I think, at least I think that's how I put it in. Ooh, might have. Beef.
So
are you referring to the mean?
Yeah.
Oh, gotcha.
Okay, so for the mean, I've got 156.850, 158.706,
Yeah,
and 118.765.
yeah.
But the variances, I've got 512.661, 636.846, and 508.566.
Yep.
Mm-hmm.
But none of those are more than 4 times the other one.
No.
Mm-hmm.
So we're good there.
So we're good on that. So we're going with A then on question 14.
The assumption that have been made is safe to assume which group comes from a normal distributed population, and we can. Yeah.
So A. Now the only thing is, if we get this one wrong, then it would be assumptions have not been met. It's not safe to assume each group comes from a normally distributed, but we can't. So in case we miss number 14, it's going to be C, just because especially that meat one is so S-curved, but like Thane said, I think it's closer than the ones that were in the example, and they said that was good. So
Yeah.
Wait, but I don't think these ones are equal, because the equal thing said if the largest is less than or equal to 4 times the smallest, then the variances is equal.
right. So in order for it to be not equal, one of these would have to be 4 times bigger than the rest of them.
Yeah.
Right.
So 508 is the smallest. If you times that by 2, you're over 1,000, and none of these are over 1,000.
Yeah.
Yeah. No, I'm saying because from the textbook, what we read is that if the largest variance is less than or equal to 4 times the smallest. So, for example, in this case, the largest one is the 636, right? And the smallest one is 508. Oh, and so the largest one is less than, okay, yeah, so they're equal. Okay, you're right.
Right. So in order for it to not be equal, one of them would have to be 2,000 more than 2,032.
Gotcha. That makes
So
sense.
if we had one of the variances that was like 2,160, say, then that would make it not equal.
So now we know that if we get this one wrong, then C is the right one.
Right, because the Q plots on that meat one was a little bit, I mean, from what we learned before on that when we did the QQ plots, if it had any S to it, it was not
Okay.
not normal. But it seems like they're getting more lenient on that the more we get into it.
Yeah.
Gotcha.
Okay. You should find degrees of freedom was 2 and 51. F of 16.074 and 0.000. The levels of significance equal to 0.05. What conclusion can you draw? Well, are those the numbers I get?
So read the numbers off again.
So we're gonna reject the null. Sorry.
No,
I'm back.
hey Wesley, you back? Do you need to catch up with us a little bit, Wes?
I'll go back and do it. Sorry, I got a phone call from career services.
Oh, you're fine. What answer did you answer last?
Oh, I'm up on. I got 10.
10 is true.
Yeah, I'll go back. I'll go back through and do it on my own.
Are you sure?
Yeah.
We can review it real quick if you want.
Well.
Come on, it's only 3 questions.
Okay, fine.
Question 11 is true.
Question 11 was the Q plots.
Yeah.
Okay.
Question 12 was 0.309.
0.309, which was the P. Remove the socks. Okay. What was the P value? Oh, okay. So you started removing
data.
Yeah. So basically, if you removed the variant 6, it goes up to 0.309.
And then the test statistic is the
F statistic. It's always right.
Right, and the P is the P value area to the right or left. Oh, so it's to the right.
Because the F statistic is always right skewed. Yeah.
All right.
And then we just answered 14 is A.
The assumptions have been met. It's safe to assume each group comes from a normally distributed population.
Yeah, but I don't know if you've done the hot dog nutrition one yet.
I was just loading in the data now.
Okay. If you want to do that, we can wait.
Okay, let's see here. So we're looking at the, is it the sodium or?
Calories.
The calories.
That's only calories?
Yeah.
Okay. Counting calories. Let's see, beef. And then meat. Is meat just a mixture? Is that what that is?
Yeah. We had that same discussion.
Wait, I was showing my son the YouTube channel for how it's made,
Oh.
We watched how it's made hot dogs, and he's like, is that really what's in hot dogs?
All the leftovers.
Well, yeah, there's a whole bunch of other stuff that goes in there too.
Oh yeah.
But yeah. All right, so I got the data in there.
Okay, so question 15, it says you should have the degrees of freedom 2 and 51, and that's what we've got.
Right. That
The F is 16.074,
mm-hmm.
and the p-value is 0.000, and we have
noted scientific.
Yeah, so we're that is true. With a level of significance of 0.05, what conclusion can you draw?
So we're rejecting it, right?
Yeah, so we're doing the alpha, which is we have
sufficient evidence to claim that all 3 hot dog types have the same mean number of calories.
I think it's C.
No, it's the other way. We have sufficient evidence to claim that all 3 hot dogs type have a different mean
number of calories.
No, no, I don't think we do. I think we have sufficient evidence to claim that at least one of the hot dog types has different mean number of calories.
I think that's right.
Yes,
just like in the prepare.
Yeah, because it's either all of them are the same or at least one is different.
True.
Yeah, that's.
All right, and then 16.
Let's see, now we're gonna do the sodiums.
Oh.
Oh, son of a gun.
I just closed it.
Okay, let me clear data here.
My computer doesn't like it when I try to drag around my Excel window.
Yeah.
Yeah.
It's the only program that does it, but it slows way down. It has a lag in the drag animation. And then poultry. Oh. We don't need that again. Now let's examine sodium levels, construct QQ plots. And you guys are making QQ plots in Excel, right?
Yeah.
Yeah, in the quantitative description sheet.
Oh. Yeah, because I was like, I don't know if I remember how to make a QQ plot in Excel.
Yeah, if you use, where we did the histograms, it's the next sheet over.
Oh, histogram.
And see, this is the same way. Yeah, the quantitative descriptive statistics.
Oh,
Excel sheet.
Gotta have another Excel sheet up.
Yeah.
Yeah.
So
I need more screens.
That's kind of like what I'm thinking, working through my small computer screen right now.
I have 2.
And you still think you need more?
I need more screens. Where's my Q plot? It's at the top. No, where is it? Oh, Q plots. It's right here. So the first one seems normal, but it does have an S. What is how do you?
Well, like we were saying earlier, they're becoming more lenient on it, but there's some wonky ones.
Because during the homework, QQ plots that we had to make, they were a little bit skewed, but they're like, yeah, but these are close enough to use. And ours are closer than those, so we're assuming that we're allowed to use it.
Mm-hmm.
And we'll just have to find out when we submit. And if we miss those 2 questions, then we know that there wasn't. But because I think the beef and the meat on the sodium part are pretty decent. The sodium, the poultry one seems a little little more skewed to me, but that's
And this, yeah, the poultry one has an outlier in it, doesn't it? How many outliers do you have to have toward? Because I'm looking at the second set of data, the meat data. Isn't there an outlier in there?
The meat ones, my meat QQ plot looks crazy. Like they look like.
Did you sort it?
Oh, I forgot that. Makes sense.
Yeah, these ones are kind of, they're iffy.
yeah, that's. I mean, that's what we're getting at too. That's.
I don't think there was a QQ plot evaluation cheat sheet that they've given us.
Yeah. Well, if you look at your homework assignment or the preparation, if you look at the QQ plots on there, those are pretty skewed from what we learned previous, but they say these are okay. QQ plots show groups are not perfectly normal, but they are probably close to enough to proceed with ANOVA.
Yeah, because I mean, okay, the first one and the third one, they look pretty normal. And the second one just looks a little bit iffy. But we could conclude that it is normal.
I mean, they're close to the line.
Yeah.
It is close to the line.
So
Okay,
we're going to go, let's see, the smallest variance and the largest variance are within parameter for the equal parameter, because 7,100 times 4 is
so what do you have for variances?
For variances, well, I have 10,492.871.
Yeah.
And then the smallest is 7,180.750.
Yeah, I've got the same things. Okay.
So, okay.
So again, I think we mark A down.
So assumptions have been met. It's okay to assume each group comes from a normally distributed population, and we can also assume that the variances are equal. I believe that's what our data description comes out to.
Yeah.
And then 17?
Yep.
Oh, and here it is talking about the poultry.
Yep. Despite the problem with the QQ plot for poultry, you decide to use ANOVA to determine the mean sodium levels are the same for all three groups. What is the p-value for this test? It is 0.179.
Yep, 0.179.
And so we have insufficient. So we do not have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels. Is the question for 18.
Yeah, B. That's the only one that we do not have, right?
Right.
Yeah.
Yeah.
Mm-hmm.
All right, I'm going in.
Okay, good luck.
It's 100%.
100%. Job, guys.
Woo.
Great job.
Yeah.
Too
bad the exam isn't buddy system, huh?
Yeah, I know.
Absolutely.
You know, I finally emailed the TA, and he said that the class average for the last exam was, I think, 74.
Oh, geez.
So.
Yeah, that makes me feel better.
Yeah, me too.
Yeah, same here.
Because I think I got a high C.
How did you do, Thane?
I got a 90.
Nice.
Oh,
Oh, way to go.
Smashed it.
Teacher's pet. Jeez.
No, I got a B.
Yeah, because I got 87. Isn't that what you got, Wes?
I got an 86. I think I missed one more than you did.
Was it 86? Yeah, but I mean, when he said that 74 was a class average, I'm like, oh, okay, we didn't do too bad.
Yeah.
Yeah.
Do you guys want? Are you guys any of you going to the doing his class at 7 o'clock?
I'm going in tomorrow.
The review.
I might be there. If not, I just watch it on the recording.
He said I asked him if he was recording it. He said he wasn't.
Oh, he wasn't? Oh,
yeah. I know.
Well,
that's
I'm
what I
gonna
said.
be in there for the recording tomorrow.
I won't be able to make it tomorrow, but I'll. Do you guys want to meet after the review on Thursday?
Yeah, that's fine.
Let me just see what he said that times up the times again.
It's Wednesday and Thursday at 7, I think.
Like they're both at 7.
One on Wednesday and the other on Thursday.
Yeah. So yeah, I'm gonna try to hit the review on Thursday, but yeah. Do you still want to hit 8:30 and go over the review?
Yeah, might as well. Because I think that there's the group quiz, right?
The group quiz, yeah.
So we'll do the group quiz on Thursday at 8:30.
And if I remember right, it's the exact same thing as the review, right?
That's what they're saying. That it's supposed to be the same questions.
Yeah.
Oh.
So it shouldn't take us too long to go through it.
Yeah.
Unless we have all different answers.
Yeah.
But I don't see that happening. So cool, guys. Well, you guys have a good time.
Yeah.
All right. Thanks. Take care.
Thanks, man.
Yeah.